Section 9.2, the quadratic formula. So in this section we're going to look at a formula that allows us to solve any type of quadratic equation. In the last section we looked at things that we could use the square root property or completing the square, but you can only use that for certain types of quadratics where with this quadratic formula it will work for all. So how this works is if we have a quadratic in the form ax squared plus bx plus c set equal to 0, then the two solutions to that equation are going to be that your two x values are negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So pretty much once we get in a quadratic in the form where it's set equal to 0, we can just fill in that formula with our a, b, and c values, and it'll give us our two answers. So we can take a look at our first problem here. We have 16x squared equals negative 44x plus 12. Well, the first thing, in order to use the quadratic formula, we can't start using that equation, that formula, until our equation is set, our quadratic is set equal to 0. Okay. So, getting it set equal to 0, we would have to add 44x to both sides, and we'd have to subtract 12 from both sides, which would give us a 16x squared. Adding 44x here to cancel it, and then adding 44x on the left-hand side will give us plus 44x, and then subtracting 12 from both sides will get us minus 12 on the left-hand side equals 0. Okay. Now, what we've looked at in the past, well, first of all, I guess comparing this to last section, could we use the square root property? The square root property won't even be possible on this kind of problem because we have this x term. For example, if we just had 16x squared equals 12, then we could have divided by 16 on both sides and then used the square root property where we square root both sides. That doesn't work, it's not possible if you have an x term. So the other way we would know how to solve something like this is we could factor. We could factor this equation or this expression on the left-hand side. Okay? But that tends to be a difficult thing to do, factoring. A lot of students forget how to do that from time to time. So instead of that, we could use factoring, or we could use this new quadratic formula we're introducing. Okay. So what you want to do to use this quadratic formula, just kind of identify what is your a, b, and c values. So a value is going to be whatever the coefficient of x squared is, in this case 16. B will be your coefficient of the x term, 44. And your c value is the constant, in this case a negative 12. So using the formula, we're going to fill it in now. Our two x values that are solutions to this equation are going to be found by, well, first of all, we have to take the opposite of b. So the opposite of 44, give us a negative 44, and plus or minus square root, open up a big square root because we're going to have a lot of things under there we need to write. Underneath the square root is going to be b squared minus 4 times a times c. So our b value is 44, so we're squaring 44 underneath the root, minus 4. And to be careful here, I would just throw things in parentheses. Your a value is 16. So 4 times a times c, your c value is negative 12. So you definitely have to throw those in parentheses when you have a negative involved. So just to be careful, just to be safe on all of those, I'd probably throw those in parentheses. Okay. You might even want to do it here with a b value that you're squaring, because if it's negative here, you have to put that in parentheses there too. Okay. And that's all going to be over 2 times our a value, so 2 times 16. Okay. So cleaning this up, simplifying underneath that radical a little bit, we're going to have x equals, we still have the negative 44 plus or minus. Well, first things, if you're kind of doing this step by step, I'd go ahead and square that b value. 44 squared gives us 1936. minus 4 times 16 times negative 12 is going to give us a negative 768. Now you could have just done that all in one step on the calculator, which will give you 2704. If you had done that, that's fine too. You don't necessarily need to write out this step. All over 2 times 16, which will give you 32 on the denominator. So again, just one more step to simplify simplify what's underneath that radical, underneath that square root. We have negative 44 plus or minus the square root of 2704. Okay, because when we subtract a negative, it's actually adding. So you'll end up getting 2704 underneath the root, all over 32. So right here is important because this determines what kind of answers you're going to get. If the value underneath that square root is a perfect square, and when you square root it, it turns into an integer, then you're going to get answers that are, well, you either get fraction answers or integer answers. You're not going to have anything with a root in it. But if it's not a perfect square, so if it's not a number that you could square root perfectly, then you're going to end up having what we call an irrational number, a number that involves a square root in it. So square rooting 2704, you should get 52. So that kind of tells you what kind of answers we're going to get. They're going to be rational answers. So answers that are either whole numbers or fractions. We're not going to have any radicals in the answer. So bringing that up here, we get x equals negative 44 plus or minus square root of 2704 is 52, all over 32, our denominator. So at this point, to find what our two individual answers will be, we could break this up into the two different equations. Okay. So our 2x solutions are going to be negative 44 minus 52 divided by 32, or negative 44 plus 52 all over 32. Okay. So in the first one, when you subtract, you end up getting x equals negative 96 over 32. And then when we add, we end up getting positive 8 over 32. So all we would be expected to do then at this point would be to reduce. Okay, reduce our fractions. So we end up getting x equals negative 96 over 32 reduces to negative 3. And 8/32 reduces to 1/4. So there are our two solutions. And so I guess what I was saying is that when you square root it, if it's a perfect square and it can square root to give you an integer, like in this case, your two solutions are going to be real numbers. Well, first of all, they're real because there's no i's involved, there's no imaginary. But then also we call them rational because there's no roots involved. Okay? So we get two real and rational roots. Two real and rational solutions. Okay? So, two of them. They're not always going to be that case, as we'll see looking through our next couple examples. Let's try to apply the square root property a few more times and see how it works out. Alright, we have 4x squared minus 8x plus 1 equals 0. So this one's already set up for us, which is nice. It's already set equal to 0. So in this case, our a value is 4, our b value is negative 8, and our c value is 1. Now, a problem like this, you might think, okay, well, I'll just do the factoring. If you're good at factoring, maybe you'd prefer to do factoring. But if this was the case, you'd have to be finding two numbers that multiply to give us, this is where you do the a times c. 4 times 1 is 4. So you'd have to find two numbers that multiply to give you 4, that add to give you negative 8. And there are no such numbers. Okay? There are no two numbers that will multiply to give you a positive 4 that can add to give you a negative 8. It's not possible. It's not going to happen. So on this particular problem, actually factoring won't even work. Okay? So because of that, we have to use the quadratic formula. Again, the nice thing about the quadratic formula is that it always works, no matter what kind of quadratic you're given. Okay? This is something, the first example we did, we could have factored, but we don't have to. We could use a quadratic formula on it, even though it's something that would have factored. Alright, so now let's apply the quadratic formula. Now we have our a, b, and c values. So we have x equals, okay, negative b. Well, our b value already is negative, so we actually are going to make it a negative, or opposite of negative 8, which will actually make that a positive 8. Plus or minus square root b squared. Again, b is negative, so you have to be careful when you write in the parentheses, or when you write it underneath the root, put it in parentheses, minus 4 times a times c. So 4 times 4 times our c value, which is 1. Okay. All over 2a. So 2 times 4 in the denominator. Alright, simplifying underneath the root is where you always want to start. So x equals, opposite of negative 8 gives us positive 8, plus or minus the square root of negative 8 squared should give you 64. Something to keep in mind, whenever, no matter what your b value is when you square it, this should always give you a positive here. So positive, but then you're subtracting something, so it might end up being a negative. 4 times 4 times 1 gives you 16. So underneath the root we have to do 64 minus 16. All over 2 times 4 is 8. Subtracting 64 minus 16, we get 48. So we have 8 plus or minus the square root of 48 over 8. Now in this example, we have 48 underneath our root, under our radical, and that's not a perfect square. Okay, if you square root 48, you're going to get a decimal. So instead of taking it to that decimal, we need to break it down. We need to break down that square root of 48. So if you remember how to do that, square root of 48. Let's do that before we go any further. Can't square root 48, but there is a factor of 48 that could be square rooted. To get 48, we could look at it as 16 times 3. That gives you 48, and we can square root 16, which will give us 4. So the square root of 48 is equivalent to 4 square roots of 3. Okay. So we want to continue with our quadratic formula using that instead of the square root of 48. So let's bring that up here. Okay. So x is going to equal 8 plus or minus 4 square roots of 3 all over 8. Okay, I just replaced the square root of 48 with 4 square roots of 3. So at this point, you could write your answer, your two answers as x minus 4 square roots of 3 over 8 and 8 plus 4 square roots of 3 over 8. However, we can reduce this, okay, and in order to do that, I think the easiest way would be to factor, okay. If your two terms in the numerator, okay, this 8 and the 4 that's out in front of the radical, if they share a common factor with the denominator, then we can kind of divide that common factor out. You could think of it like pulling out a GCF. Okay. 4 goes into 8 and 4 goes into 4, so we can pull out a 4 up top. 4 times 2 would give us 8, and then we'd have our plus and minus. 4 times 1 would give you, 4 times 1 would give you the 4, so we'd have 1 square root of 3. Although you don't really need to have that 1 written out there. Typically you won't see it written. And then down below 8 we could think of as 4 times 2. So then looking at it this way, those 4s, we have a common factor of a 4 that will divide out. Okay. So all we're doing right now, I mean this is not incorrect, but we're just kind of writing it in lowest terms, which you will be expected to do in my math lab. So after the 4's divide out, we're just left with 2 plus or minus the square root of 3. You won't normally see that 1 written out front. All over 2. So in order to write your two answers in my math lab, you'll have to write it as 2 minus the square root of 3 over 2. And then usually just have you put a comma, and then 2 plus the square root of 3 all over 2. Okay. And these answers, they're both real because there's no i's, there's no imaginary, unit I involved with them, because it was still a positive square root we were taking. But because they have a radical symbol in them, we consider these irrational. Okay, they're rational if they don't have the roots in them, irrational if you have a square root in them. Okay. So here we get 2 real and irrational roots, or 2 real and irrational solutions. All right. Looking at one other kind of example we might end up with. Well, actually, this example looks completely different to start with, and you are going to see something like this in the homework, so I'll show it to you now. Well, first of all, this isn't 10.2, this is 9.2. Right. So continuing here with 9.2, we have to solve, but this expression has parentheses in it, okay, a little bit different than the first two we already looked at. And also it's not set equal to 0. So in order to handle this problem, we can't use the quadratic formula yet. We would first need to FOIL the left-hand side, that double parenthesis. We'd have to FOIL to expand that out. And then we'd need to get it set equal to 0 by getting that minus 8 over on the left-hand side. Alright, so first things first, let's FOIL this. Because we really can't combine, if we move the 8 over, minus 8, we couldn't combine it until we got rid of these parentheses. So if we FOIL this, 9x times x is going to give us 9x squared. 9x times negative 1 will give us negative 9x. But then 3 times x will give us a positive 3x. And those will combine to give us a minus 6x. And then 3 times negative 1 will give us a minus 3. Alright. So now we can take this, and before we can use the quadratic formula, we need to get this equation set equal to 0. So we need to add 8 to both sides of the equation. Adding 8 here will cancel it out, make it a 0. And then negative 3, when we add the 8 here, will make that become a 5. So this becomes 9x squared minus 6x plus 5 equals 0. Once again, we have our a value, 9, b value, negative 6, c value, positive 5. Okay. You could try to factor this one as well. However, this is going to be one that's not even possible to factor. So don't bother wasting your time with that. Just go ahead and use the quadratic formula. Alright. So, plugging this into the quadratic formula, first thing we start with is the negative b of the b value. So the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times our a value 9 times our c value, 5. Since those are positives, we don't have to put them in the parentheses. All over 2a, which is going to give us 2 times 9. Okay. So underneath the radical, let's simplify, like we did on the last few problems. Opposite of negative 6 gives us positive 6, plus or minus the square root of, okay, negative 6 squared will give you positive 36, minus 4 times 9 times 5 gives you 180. All over 2 times 9 is going to give you 18. Okay. So different about this one, when you actually subtract underneath the square root, we're going to get a negative because we have a smaller number subtracting a larger number from it, giving us negative 144. Okay. So here you can tell by what's under the root the type of answers we're going to get. Well, they're going to have to be imaginary because we're square rooting a negative number. So there's going to be an I, the i's involved when we have a negative underneath the square root. Okay. So square rooting 144 actually would give us 12. So it actually is a perfect square. It's just we need to pull out an I in order to handle the negative part of it. Okay. So that's coming up here. The square root of negative 144. Just to kind of go back to what we talked about in the complex numbers section. I believe 8.7. This is equivalent to the square root of negative 1 times the square root of 144. And the square root of 144 is 12. And to handle that negative 1, remember that just becomes I. So 12i is what we're going to use in our quadratic formula here instead of the square root of negative 144. Alright, so we can bring that up here. And continue with the quadratic formula. X equals 6 plus or minus 12i over 18. So we could write our answers as 6 minus 12i over 18 and 6 plus 12i over 18. Except, once again, we can factor to try to reduce the fractions that we'll have. Okay, 6 and 12 and 18 all share a common factor, and that common factor would be 6. 6 goes into 6, 6 goes into 12, and 6 goes into 18. So we can rewrite this then as x equals, if we pull 6 out up top, we'd be left with 6 times 1 to get back to 6. Then the plus or minus 6 times 2i would give us 12i. And then we can think of 18 as 6 times 3. So here we can divide out our 6's. Okay. So our actual answers, well, I guess at this point we're left with 1 plus 2i up top over 3. Okay. So to write these two answers, we could write it as, oh sorry, I forgot the plus or minus. So x equals 1 minus 2i over 3, or 1 plus 2i over 3. Okay. And so in problems like these, where you get a negative underneath the square root, you're going to have imaginary solutions for sure, but not necessarily that still have a root in it, because 144 was still a perfect square we didn't end, and that ended up giving us 12 when we square rooted. We don't have a root in our answer. We don't have a radical symbol, but we do have the I. So here we end up getting two imaginary solutions. Okay. And then the last part of this section just kind of describes something we've already talked about, but we're just going to give a name to it now. And that is the discriminant. The discriminant is something that helps you determine if your solutions are going to be rational, which means they're just going to be regular numbers, maybe fractions, but they're not going to have the roots in them. Or are they going to be irrational, which means they're going to have the square roots in them. Or are they going to be complex, meaning are they going to have the i's in them. And how we determine this discriminant, the discriminant is the value that's underneath the square root when we use the quadratic formula, that b squared minus 4ac. So just by looking at that discriminant value, without actually doing the whole quadratic formula, you can tell what type of solutions you're going to get. So our first, possibility, if it's positive and it's a perfect square, then you're going to get two rational solutions. Okay, if you end up with something like 36 underneath the square root, that'll end up being, square rooting down to 6. So you're going to have answers that are just numbers. They don't have the roots in your solutions then. So these could be rationals, meaning they could be integers or whole numbers. Integers mean whole numbers, or they might end up being fractions. Okay, again, flip back, look at our first example. Of these notes. 2704 was positive, and it was a perfect square, because square root would be 52. So our answers were real and rational. No i's involved, just either a whole number or a fraction. Okay. Another possibility is if it's positive, but if it's not a perfect square. Okay, that was like our second example. If that's the case, you're going to get two irrational solutions. Okay, in other words, they're going to have the square roots involved in them. One we didn't talk about, actually, was if you had 0 underneath the square root for your discriminant value. If you square root 0, it actually just gives you 0. So then when you were doing like the plus or minus part, adding 0 and subtracting 0, you're actually not going to get two roots. This is the one case where you only get one solution. So, and it is going to be a rational solution, because if you square root 0, it will just give you 0. So you have one rational solution in this case, which again will either be a whole number, an integer, or it may end up being a fraction, but there aren't going to be roots involved, there aren't going to be the i's for the imaginaries involved. And then lastly, if you get a negative underneath the root, the square root, of course then you're going to have, that's going to involve complex solutions. Okay, so by complex I mean imaginary, which means they will involve the I. And they may be a root, but it doesn't have to be. Okay. Doesn't have to be a root. If it's a perfect square negative, like 144, then it was going to involve i's. It's not going to have roots in the answer. But if it was something that wasn't a perfect square and it was negative, then it's going to have i's and square roots in the answer. Alright, so we can look at our problems and determine that right off the bat, right from looking at the problem without actually having to use the whole quadratic formula. So an example like 6x squared minus x minus 15. We can come in here and determine what our discriminant is. Okay, our a value is 6. Our b value technically is -1. C value -15. So if we want to know what kind of solutions we're going to have, we can just think about the b squared minus 4ac, whatever that value will be, because that's what's going to be underneath the square root. So b squared would be negative 1 squared minus 4 times a is 6 times c is negative 15. Okay. Don't need to put that over 2a or anything, we're just looking at that value. B squared minus 4ac. Negative 1 squared gives you 1, minus 4 times 6 times negative 15 gives you negative 360. Okay. And if you do 1 minus negative 360, you get 361. So it's positive. So we know it's either going to give us 2 rational or 2 irrational roots, two rational or 2 irrational solutions, depending if that's a perfect square. So try square rooting 361 and you end up getting 19. Okay, 361 actually equals 19 squared. So because of that, since it's a positive and it's a perfect square, we're going to get 2 rational solutions. Okay. So then same idea on the next example, 4x squared plus x plus 1 equals 0. Since it's set equal to 0, we can look at what is our a, b, and c. So a is 4, b is 1, c is 1. Again, we want to calculate what is our b squared minus 4ac value. Again, we call that the discriminant. Okay. So, what is the discriminant in this case? B squared would give us 1 squared minus 4 times our a value, which is 4, times our c value, which is 1. All over, oh no, sorry, we're not putting that over anything. We're just calculating that b squared minus 4ac. 1 squared gives us 1, minus 4 times 1 gives us 16, and that's going to give us negative 15. So, because we get a negative value, that means we know we're going to get 2 complex solutions. So, in other words, they're going to have i's in the answers. Okay. And because 15 isn't a perfect square, it's also going to have roots. So, in a problem like that, not only would it have i's, it's also going to have the square roots in the answer too. So, the problem like that would be, kind of a real mess when you write the final answer. And that is all, make sure, yes, all we have for section 9.2, quadratic formula.